So this is where we started the problem. In the first part of class, we already tracked through this visually. So we're going to kind of track back through what you did, but this time we're going to add in the numbers to go with it. Before we can do that, we have to talk a little bit about numbers for a minute. Right now, I have two different things that I don't know. I have a bag, and I don't know what's in the bags. I also have a box, and I don't know what's in the boxes. Two different things. In math, we said we're going to translate this to numbers. What do we use in math as a placeholder for something that we don't know? X. Or what if I have more than one thing I'm missing? Yeah, X or Y, which are variables, right? So I have two different things that I don't know. Since I'm going to translate the same problem into numbers, those bags and boxes, those are going to turn into variables, which are placeholders for the things that we don't know. It doesn't really matter what letter you use for each one, as long as you keep track of which one's the bag and which one's the box. Most people go for X and Y. That's kind of the generic accepted one because X and Y on a graph. That's why people go for that. So off to the side, I'm just going to make a little key just so we can keep track of what's what. And we'll say that the bags are going to be X and the boxes are going to be Y when we do this with numbers. Each of these scales you were looking at actually represents an equation. So for the last day and a half, you actually been working with equations, but you've been working with it visually. Taylor, you think you'd see what the equations are?
So if they equal, like if they equal each other, then you have to put like an equal sign.
Yeah, if they equal each other, then it's going to turn into an equal sign. You're right.
Yeah, and then you like I'm not too sure on how to like get the numbers and write the equation out, but like eventually you have to like kind of simplify or do like cross.
Yeah, we're going to get to that in a minute. But you're right, these scales represent equations because the two sides are worth the same amount, which means they're equal. But the question is, okay, we have to get the actual things on the scales turned into numbers. Remember we said bag is an X. So if I have a bag sitting here, what am I going to have in my equation? An X. And then I have 3 coins that I actually know. So what would that be?
Plus 3.
Right. An unknown number of coins plus 3 more coins. And on the other side I have a box. That's different than a... Ah. There's our scale turned into an equation. How about this one? If I have 2 bags, what's that going to turn into? 2x, right. And what's this going to turn into? There we go. You guys are seeing it. It's still the exact same scales, but now instead of drawing a picture, I'm writing it out with numbers. Okay, now let's see if we could take our steps for solving this and turn it into numbers. And I'm actually going to number these because when you guys track through this in the warm-up, the strategy that you guys kind of pieced together between some different people was actually spot on with how you do this. But if we could break it down a little bit, it'll make it more useful, right? So let's see if we could track back through this. You have to remember back a couple of hours. What was the very first thing we did? And the reason that the strategy is called substitution. Keone? Yeah, exactly. So the first step in the substitution strategy is the step that it gets its name from. And that's always the first thing you want to do when you're looking at a problem like this. Are you done? You want to look and find out or try and make a substitution or a switch. And what we want to switch, we want to do so that we only have bags or we only have boxes when we're done, because then we can figure out whatever the thing is that we have left. So the first thing, which is what you guys saw and did, was look for an item that can be swapped or switched for something equivalent. And when you guys did this, I'm going to put one more thing down here before we actually show what that step looks like with numbers. you guys probably didn't even realize this, but you actually did something important that becomes important with the numbers to keep you the equations, to keep you from getting scrambled. When you guys did this, you looked over here to see what the box was worth, right? Which scale did you actually replace the box on?
The other one.
Yeah. So you might not have even thought about that when you did it, because when you're doing it visually, it's kind of instinctive. But that's actually important with the equations. One equation usually will tell you what you're swapping, and the other equation or the other scale is where you actually make the swap. So that's kind of a hint or a good tip to keep you from getting confused with this. So one scale or equation, if you're doing numbers, tells you what to swap. So in this case, the left scale tells me, okay, I can swap the box with a bag and 3 coins. The other scale is where the swap actually happens. The reason I mention that is because when people are working with numbers, it's really easy to get lost in the numbers. And sometimes your attention's up here, right? Now it is. Sometimes people kind of get lost in the numbers and they'll say, okay, I'm going to swap a box with a bag and 2 coins. And so they'll take the box off of this side and put a bag and 2 coins on the same scale. But that didn't help me because I haven't compared it to the other scale yet, right? So you have to remember, system of equations is a comparison. I have to be using both scales, otherwise I don't have a comparison. Okay, so let's actually do this step. I'm going to scoot this up a little bit. So we'll do the visual first, and then we'll show what it looks like with numbers. So you guys told me the scale on the right, which originally looked like this, I can take the box, so I'm going to cross the box off. And since a bag and 3 coins is the same as a box, I can replace it with a bag and 3 coins. So I took some weight off, but then I put something right back that weighs the same amount. So I'm still good. I'm still balanced. Let's think about what happens with the equations, though. Here's what the equation originally was, right? I took this box and I swapped it out. The box is the y, right? And what I swapped it out with was a bag and 3 coins. That's our x plus 3, right? It's worth the same as a box as a bag and 3 coins. So instead of that box, now I have a bag and 3 coins sitting there. And so I highlighted the part that shows the switch we made visually. Now, when you're looking at the scale, though, if you were looking at this visually and I said, what's sitting there, you wouldn't say a bag and 3 coins and then another coin. What would you tell me?
Bag and 4 bags.
Right. You would total it up, right? So what you did visually in your head is you simplified, because x plus 3 plus 1 is really x plus 4, right? Okay, so there's our first step. We just switched it out, right? So now I have 2 bags on one side and I have a bag and 3 coins on the other side. Now I'm going to re-sketch this just for a minute. I know it's a little bit of sketching, but it helps to re-sketch it. Otherwise our sketch gets really messy and it's hard to see where we're going. Okay, so the second step started here. Do you guys remember what the next thing that you told me to do was, the first part of class? To figure out what's in one bag? Because I could figure out the bags. I don't have any boxes left. It's just bags. So if I reason through this a little bit, I can figure it out. Isaac? Yeah, I have a bag on both sides, and I know the bags weigh the same amount, right? So if I pick a bag up off of this side, and I pick one up off of that side, my scales still sit balanced, but, oh look, 1 bag's left, and what's sitting on the other side? So we just figured out a bag is 4 coins, right? Numerically, here's what this looks like. We started with 2 bags, and then 1 bag and 4 coins, and we took a bag off of each side, right? Take away bag, take away bag. I want to point something out here. Do you guys realize when you take away a bag, what you're doing is you're just solving the equation we made? If I gave you 2x equals x plus 4, most of you guys would solve that by subtracting x from both sides, right? So visually, you guys were actually visually reasoning through solving equation steps before you even realized what you were doing. Bag is 4 coins, right? Now, we're not done yet, though. There's one more thing. So this part, all we're doing here, we're really just solving the equation we made. So we're making a switch that makes it so we only have boxes or only have bags, and then that gives us an equation that we can solve, and when we're done solving the equation, that gives us one of our 2 things. But that gives us the bags. What else do we have to account for?
Boxes.
The boxes. So there's one more step, and that's once you get the first item, you have to go back and get the second one. Now that I know the first one, I know what's in a bag, I can use that to help me get the box. Use the first item to get the second. I'm going to zoom this out just for a minute so that we can see the beginning of this. I've got 2 scales. Which scale is going to be the easiest for me to figure out what's in a box, the left or the right? Yeah. What is it about the left scale that tells you that's the easiest one that tells me what's in a box? Yeah, I've got a box sitting there by itself, and that's exactly what I'm trying to figure out, right? So it helps to go back to that equation and basically drop in what I know, right? So if I go back to that scale, okay, here's my box. Here's my bag and my 3 coins. Well, now I know that this bag actually has 4 coins inside it, right? Which means the box has to be 7, which is what you guys told me the first part of class, right? With numbers, what you did was you took this first scale and you just filled in x, because we know what x is. We figured out x is 4, so we could say, okay, fill in a 4. 4 plus 3 is 7. There's our box and there's our bag, right?